Hello everyone, my name is S.N. Patil. In this video lecture, we discuss the Regula Falsi method. Regula Falsi method is also known as method of false position, as false position of curve is taken as initial approximation. Let y is equal to f of x with a curve, and the curve AB, see the diagram. See, this is the y is equal to f of x. B represented the curve, and is here we join this curve as a point A and B. Okay, and the root of this curve is a alpha. See, the curve is intersect this point. That is the alpha. Okay, and the false position of the curve is taken. Means we join this curve by these 2 points, capital A and capital B, and we consider the initial root is x0. That's why we call this method as a false position method. So instead of alpha, we consider the first approximation root is x0. Then we shift this chord, means at A dash point to B, then second false position. This is the second false position. Then similarly, next is x2. In this way, we reach to the desired root. Okay, we reach to the correct root of the equation y is equal to f of x. So here, for that we use the concept is we find the equation of this equation of the line AB. Let us see. AB with x-axis. Now equation of chord AB in 2 point form A is given by the equation of the line y minus intercepting point. Okay, this is the slope of that chord. We know the equation of the line y is equal to mx, y minus y naught is equal to m and x minus x naught. In this way, this is the slope of that line. The slope of this line is, see, this is the b comma f of b, and this is the a comma f of a. The slope is y2 minus y1, means f of b minus f of a divided by x2 minus x1, means this is the x2, b minus a. And the equation of this chord AB is y minus, that is the point of this chord. Okay, that is the image of the A is f of A into is equal to into slope. Slope is f of B minus f of A divided by B minus A. Okay, into x minus the point A. So this is the equation of the chord AB. Okay, and the we approximate the first root is x0, and which is false. That's why we call the false position method. The position of this root is false. Okay. Now here, to find the first approximate root x0, we put y is equal to 0. That is the point of intersection of chord AB with x-axis. So that put y is equal to 0. When we put y is equal to 0 here, then we get minus f of a, the slope as it is x0 minus a. Okay. Now the denominator b minus a is multiplied here, and f of b minus f of a is divided. That is x0 is equal to, put minus a in right hand side. So this is the formula for finding the first false position. Okay. Now successive approximation x2, x3 are given by the point of intersection of chord a dash b, a double dash b with x axis until the root is found to be of desired accuracy. Okay. Now here we change this formula. So instead of x naught, we write the formula as a x2 is equal to x naught minus f of x naught divided by f of x1 minus f of x naught, x1 minus x naught. See, suppose this is the curve, okay, and this is the x naught point, and this is the x1 point. So instead of a and b, that is the root is lies between x naught and x1, and this is the chord a b. Okay, so this is the first position, say x2, that is the false position of the root. Then we joining the second chord to this point. Suppose this is the a dash. Now this is the second approximation. See, for our simplicity, instead of x naught we write the x2 here, and instead of ab, means instead of x naught we write x2, and instead of a we write x naught, and for b we write x1. That is, the root is lies between x naught and x1, x naught and x1. That is, the curve is passing through this 2 point x naught and x1, and this is the first false position of the root. Instead of x naught we consider the x2. Okay, then second approximation, that is the x3. Then again joining the chord, see, from this p point, this is the x4. In this way we tends to this accurate root, that is suppose alpha. This process is regular Falsi process to find the real roots. Okay, now repeat this process until root is found to the desired accuracy. Getting it? This is the formula for finding the root, and here the x naught and x1 indicate the curve is passing through. This is the x naught point, this is the x1 point. That is, the curve is passing through the interval x naught and x1. Otherwise, the root is lies between x naught and x1. So here in the first, we consider the root is lies between a and b. We change this formula. Instead of x naught, we consider x2, and for AB, for A we take x naught, and for B we take the x1. Let us see the example. Some remark is here. The remark is rate of convergence is much faster than that bisection method. Remember, unlike bisection method, one end point will converge to the actual root A, alpha, whereas the other end of always remains fixed. See, we have seen this end is fixed, and the first chord, the false position is x2, that shift to the x3, then shift to the x4, but another end is fixed. Okay, as a result, regular Falsi method has linear convergence. Now example, find the real root of the equation x cube plus x minus 1 is equal to 0 lying between 0 and 1 by method of false position to 3 decimal places. Instead of 3, it may be a 4 decimal. Okay. Now here interval is given. Sometimes interval is not given. If not, then calculate the interval by intermediate value theorem. Okay. Now let f of x is equal to given equation x cube plus x minus 1. Here interval is given, then we consider, see, it means what? This is the first point x naught. X naught is 0. And this is the second point 1. That is the x1. Okay. The root is lies between x naught and x1. So x naught is 0, x1 is 1. We find out the value of x naught and x1. When we put x naught means 0. Then we get -1. Substitute the value of 0 here. Okay, and now put x1 is equal to 1 in polynomial, we get the 1. So here we get the opposite sign. It means the root is lies between in the interval 0 and 1. Okay, if interval is not given, use the same concept. Okay, now the root lies between 0 and 1. Now the first approximation is x2 is equal to x naught minus f of x naught divided by f of x1 minus f of x naught into x1 minus x naught in numerator. Okay, now put the value of x naught is 0, then x1 is 1, substitute here. Okay, what is the value of f of 0? The value of f of 0 is -1, substitute the -1. Value of f of 1 is 1, f of 0 is -1. Okay, now simplify. Here minus plus, here 1, here minus plus, that is 1 plus 1, that is 2, that is plus 1 by 2, that is x2 is 0.5. That is the first approximation. Now put this x2 value, put in equation 1. Substitute here in equation 1. Now this equation 1 decide. Now here we get the x2 point. Now this is the negative point. See here, negative, and this is the positive. Now we put x2 here. If this value is positive, then root lies between x0 and x2. If this value is negative, then root lies between x2 and x1. Let us see. When we put the 0.5 cube plus 0.5 minus 1 is equal to minus. So we get the minus value. It means root lies between x2 and x1. Okay. Now, next approximation is second approximation. Then here x3. x3 is equal to x2 minus. Just change x0 here in this formula. Here, instead of x0, write x2. Okay. Now substitute the value of x2. x2 is 0.5, x1 is 1. Substituting the value, we get this. Okay. Now what is the value of f of 0.5? See, we have calculated. F of 0.5 is minus 0.375. We substitute here. Similarly, the value of f of 1. F of 1 is calculated, that is 1. Substitute here. Okay. Now here minus plus. Here 0.5. Here minus plus, that is 1.375. So we get 0.6363363. This is the second approximation. Okay, now put this value in equation. Put in equation number 1. Substitute here. Okay, now the condition is what? This is the x2 point and this is the x1. We have seen in remark, the one point is fixed, end point is fixed. Okay, now x2 is shifted. Now here we get the x3. The x2 we have calculated. The image of x2 is negative and image of x1 means what? 1 is positive. Okay, now put x3 in equation number 1. If this value is positive, then root lies between x2 and x3. If this value is negative, then root lies between x3 and x1. Let us see. So we get the negative value. It means root lies between x3 and x1. That is the intermediate value theorem. We have already discussed in previous two methods, bisection and iteration method. Okay. Now the next approximation X4. So here, instead of X2, write X3 only and keep X1 as it is. Same formula. See here, X3, X3, X3 and keep X1 as it is. Now substitute the value of X3 here. Substitute the value of X1. Okay. Now substitute the value of f of 0.636363. This is minus. Okay. And value of f of 1. Value of f of 1 is 1. Substitute here. Just. So we get the. Now here minus and this minus, 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 plus. And here 1 minus 0.63, 0.63, 0.63. Here we get the sum value, which is multiplied here. And here we get minus, minus, plus 1.105937. Now by calci, we get the X4 is equal to 0.671196. Okay. Now see, this is the X3, and this is X1. Now the position is shifted here, X4. Okay. Now X3 is negative. We have calculated its image is negative and the image of X1 is positive. Now let us see what we get the image of X4. Now put this value in equation number 1. Substitute here, then we get the negative value. This is the negative value. It means we get negative value. The X4 is negative and X1 we have already calculated, that is the positive. It means root lies between X4 and X1. X4 and X1. Okay. Now the next formula for the next iteration for the X5. Then here X5 and instead of X3, write the X4. See, as it is for. Now substitute the value of X4 and X1. Okay, now the substitute the value of its images. Okay, here minus, minus, plus, and this simplification, here we get the sum value, and here minus, minus, plus, that is 1.026427. Simplify by calci, then we get the X5. Okay. Now see, we just discussed the root is lies between X4 and X1. The image of X4 is negative and image of X1 is positive. Okay. Now this is the X5 point. This is X5 point. Now let us find its image. So put this X5 in equation number 1. Put in equation 1, then we get negative value. So this is a negative. It means root lies between X5 and X1. Okay. Now the next iteration. Here then the value, here suffix value is 6 and instead of X4, write X5, X5, X5. Now put the value of X5, put the value of X1 here. Okay. Now put the value of image of f of 0.679662. Its image we have calculated is minus, and image of f of 1 is already calculated, that is 1. Okay. Now this is minus, minus, plus, minus, minus, plus, here this minus, minus, plus 1.006375. Simplify this by calci, we get the next iteration, that is the iteration number 4. Okay. Now the question is find the correct root up to correct root to 3 decimal places. Now 1, 2, 3. Okay. Now the fourth position is greater than 5. That is the value of desired root is 0.6868. Now here the fourth position is greater than 5. Then we add here 1. Okay, we get 0.682 value. Okay, now the some example for you. Homework. This is the first problem. Homework for you. Here the mention already, the root is lies between 1 and 2. Okay, follow the same problem as it is. Now second homework. The equation is x cube minus 9x plus 1 is equal to 0 and root lies between 2 and 4. Its answer is given, that is 2.9310. Okay, now some problem, the interval is not given. Okay, in which use the intermediate value theorem. First identify the interval. Let us see the problem. The question is find the real root of the equation x cube minus x minus 4 is equal to 0 by method of false position. Okay, yeah, instead of that Regula Falsi method, 2, 3 decimal places. Okay, let f of x is equal to x cube minus x minus 4. So here first we find out the interval. So use the trial method. First put 0. If you put 0 here, then we get the minus 4. If you put 1, then again we get the minus 1. So start from the 1. Start from the 1. So we get minus sign. Now put next value, next number 2. Okay. Then 2 cube is 8 minus 2. And this minus 4 minus 6. 8 minus 6, that is 2. Okay. That is the opposite side. Minus and plus. It means the root is lies between 1 and 2. Okay, say x0 as a 1 and x1 is equal to 2. Okay, let us find the first approximation. Then we start from the x2. x2 is equal to x0 minus image of x0 divided by the difference between the images f of x1 and x2, and here difference between x1 and x0. Substitute the value. x0 is 1, x1 is 2. Okay. We have substituted value. Now put the value of f of 1. f of 1 is minus 4. Here minus 4. And value of f of 2 is plus 2. Okay, see here the minus minus plus. And here minus minus plus. Okay, so we get 1.6666. Okay, 6666, and here we rounded. Okay, that is 67. Now see, this is the x0 point. x0 means what? 1. Okay, and this is the x1 point. x1 means 2. The value of x0 is negative when we put the x0, and value of x2 is positive. That is root lies between x0 and x1. Now we find the next approximate root, that is x2. We got 1.6667. Okay, now put this value in equation 1. Put in equation 1. Okay, if we get the value plus, then root is shifted here in between x0 and x2. If this value is negative, then root lies between x2 and x1. Let us see. When we substitute the value in equation 1, then we get the negative value. Okay, it means root lies between x2 and x1. Now the next approximation, x3. Now instead of x0, only write the x2, remaining value x1 keep as it is. Substitute the value of x2 and its images, x1 and its image. Okay, so we get this. Now substitute the value of image of f of 1.66667, image of f of 2, image of f of 2 is 2. Okay. Here this minus minus plus, that is 3.037035. Here we get the negative value, here minus minus plus Now through Cal C, we get x3 is equal to 1.439025. Okay. Now see, the root is lies between x2 and x1. x2 is negative. See, we have just check here, and x1 we already calculated. F of x1 is positive. Now we shift the chord, then here x3. Now let us check the value of image of x3. For that, substitute the value of x3 in equation 1. Okay, then equation 1 become, okay, the resultant is negative. It means root lies between x3 and x1. Okay, now the next iteration. Instead of x2, write x3 and keep x1 as it is. Substitute value of x3, x1. Now the substitute the value of its image. The image of f of 1.439025 is minus 2.45910. To substitute here image, substitute the image of f of 2. Okay. So here minus plus 4.459102. Here we get the negative value. Simplify. Then we get the x4 as a 1.196912. Okay. Now here we stop the performing the iteration. Now the question is, by false position method, find the answer to 3 decimal places. That is 1, 2, 3. Okay. Now the 4th position is greater than 5. Greater than 5. Adjustment. Then the answer is x4 is equal to 1.19. If this 4th position is greater than 5, then add the 1 in a 3rd position. Okay, 1.197. This is approximate root by false position. Okay. Thank you for watching the video.